Precalc 1.8 day 2, we're going to start off with definition of intercepts. You guys know what these are, but to be an x-intercept or a y-intercept means to cross the x or y axis. Right. And so we can see that if I wanted to find x-intercepts, I have to set the equation or the y equal to 0 and then to solve for x, which basically says, hey, I'm going to cross here, here, and here. This is, what kind of graph is this one? You guys don't know? It's an x cubed type graph, yes. It's a cubic, third degree. And so we will have 3 x-intercepts, potentially. Potentially only one. Can't be 0 because you're always going to be going down to infinity or up to infinity, so therefore it'll always cross, at least on a cubic. Y-intercepts, I'll put a 0 in for x, solve it for y. This one is definitely something that's been moved or changed in some way, so it's a little bit harder to identify the main parent graph to that. But you can see that in this case, we're crossing the y-axis at least twice, possibly 3 times, because the picture got cut off here. And we also have an x-intercept, just like we have a y-intercept up here. So it's just any coordinates that cross the y-axis. We know that. That shouldn't be an issue. So to put this to work, let's find our x-intercepts. We graphed this one already on a slide before, but now what if I wanted to make a better looking graph than just making a t-chart and just saying, hey, what can I get for my points? Well, one of those ways is to find your x-intercepts. So according to what we had before on the last slide, if I want to find x-intercepts, what has to be equal to 0? The y. So change it. And now we just want to solve for x. Now the other options, when there's things like this, especially when it's a quadratic, but you should be going through your factoring rules. Pulling out common terms, factor by grouping, difference of squares, difference of cubes, factoring normal trinomials with a equal 1 when a does not equal 1. You have a lot of different techniques to solve for x. In this case, what do I have to do? Can I do the difference of squares? Technically, yes, but no. I could force 2 to be a perfect square, which it's not, because it would be a perfect square of what? A square root of 2. So technically, if you really wanted to, we could just say, hey, this does actually become x, the square root of 2, square root of 2, a plus and a minus. Does that work? If I FOIL that out, I will get x squared minus 2. Sometimes it's really easy to do it this way because now, what's one of my answers? Well, I'd have to set them equal to 0, right? So x equals square root of 2, x equals negative square root of 2. We should know how to do that. What if I didn't do that, though? What if I said, hey, there's a better way maybe to do this? It's x squared minus 2 equals 0. What's the other way? Yeah, add 2, square root. So in this case, I'd have 2 equals x squared, square root, square root. The only thing you can't forget to do is plus or minus. That's a really big square root. So it's plus or minus the square root of 2 equals x, which is exactly what we had below. So that doesn't change anything. So those are your solutions, but what does it really mean? They are your solutions. They are our x-intercepts. What would they look like as x-intercepts? They both will have what for y? 0, because when I plug that in, I do get 0. And then one of them is square root of 2, and negative square root of 2 is the other one. So square root of 2 is 0, and negative square root of 2, comma, 0 are your x-intercepts. X-intercepts are points. They're not just a single value. I think we all understand if I say, hey, my x-intercepts are square root of 2 and negative square root of 2, we kind of can visualize where they are, but they are points. It's just like when we graph our lines in slope-intercept form and we plot our y-intercept. If our y-intercept's at 4, it's at 0, 4. That's why. It's a point. Next thing, circles. We've dealt with circles before. Once, maybe even twice. Up there is the standard form of a circle when it's centered anywhere that has h and k. And so we have x minus h squared plus y minus k squared equals r squared, where r is the radius of your circle. And h and k, actually I don't have that up here, I'll write that on here, where h and k is the center. It's very nice. I like to write equations for circles because a lot of times I'm given a center and a radius. I just plug it into the formula, I have it. Or the other way around. I give you a formula and say what is the center and what is the radius. The other cool thing about having a center and a radius is the fact that it's really easy to graph then. There's 2 steps to graph these things. Step number 1, plot the center. Easy enough. And 2, take your radius and move left, right, up, and down that far. So if the radius is 3, I'm going to take 3 steps to the left, up, to the right, and down, and then draw the circle around. That's how easy these can be. But you need to identify those things. Now, second part of this is that what happens when it is centered at 0, 0. So h and k are 0. And when they're 0, they're just not there, and it's just x squared plus y squared equals r squared. Easy enough. So therefore, if I asked you to graph the first one, can you do that? Where's the center? 0, 0. What's your radius? It's 5. So you have 0, 0 is your center. R squared equals 25, or we would say R is 5. Wait a minute. I would have to take the square root, wouldn't I? But when I square root, I should do plus or minus. How come I don't do that here? Because a radius cannot be negative. Right. So that's why it's 5. And so, easy enough. I'm centered at 0, 0. So I put a dot there, and I'm going to go 1, 2, 3, 4, 5, put a dot. 1, 2, 3, 4, 5. What's that? Drawing could be the hardest, but actually putting the circle on, yes, is very hard. So there is my circle. It's not perfect, but it's there. The second one's not centered at 0, 0. That's okay, though. What is my center? 2, negative 1. Remember, it's the opposite of what you see, because the original equation has x minus h, and h would have to be positive to be negative inside. So to be positive here, for this y plus 1, is that you were actually subtracting a negative. So that's why it's negative 1. And again, your radius is what? 5. Some of these are pretty straightforward. It's not always going to be a nice number. It could be the square root of 28 instead, or 28 there, and then you would have to take the square root of 28. So, doing the exact same thing. 1, 2, 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there is the circle again. Guys, make sure that you guys understand that the center of the circle is actually not part of the circle. It was part of the process of graphing the circle. So the only real solutions to this are any spot that's on your circle. So all of these parts that make up the circle around the outer edge, if I was to plug them in for x and y, will give me 25. If you actually think about it, x minus something squared plus y minus something squared equals something squared. Isn't that just the distance formula? If I squared both sides, or Pythagorean's theorem? Yes, because the distance formula is the Pythagorean's theorem as well. So that's what we're using here. So what happens though if I gave you points and a radius? Could you write the equation? Or what happens if I just gave you 2 points? Could you write the equation? I would hope you could. And so part A says write the equation of a circle that has a radius of 3 and it has a center at 2, -5. So we'll do part A right here. Now this is not centered at 0, 0. So I have to use the first equation we were given of x minus h squared plus y minus k squared equals r squared, correct? What's h? It's 2. So in the equation it looks like it's x minus 2 squared. What's k? So it's minus a -5, or we will go right to plus, equals 3 squared, or 9. 3 is the radius. The second one is, I'm guessing there's probably not too many questions on that one. The second one, though, is write the equation that has the points 1, 8, and q, or p is 1, 8, and q is 5, -6, as the endpoints of the diameter. Well, that's an interesting one. Yes, I agree, we'll use the midpoint. Midpoint will help us find the center. So, midpoint formula, without having to write it down, would be what? Add the x's, divide by 2. Add the y's, divide by 2. 1 plus 6 over 2, comma, 8 plus -6 over 2. Oh, 1 plus 5. So, 3 and 1. So there's our center. So now we know our h and k. Now we just need to know the radius. And the radius goes from the what to the what?
The vertex to the outside of the curve.
Outside, right. From the center to the outside. Do we have those?
We have the center.
We have the center.
We don't know the outside.
We do know the outside. We have 2 points on the outside.
But we can graph it, and we can do the distance formula to figure it out.
You can graph it and then use the distance formula, or if you don't want to graph it, you can just use the distance formula. What if I call this, guys? This is going to be called point 2. Is that okay? Which one of those up top do you want to use as point 1?
1 and 8.
1 and 8. So this is point 1. So distance, or I'm going to call r, not distance. R is equal to the square root of what?
You got yourself some 3 minus 1 squared.
Yep.
1 minus 8 squared. That should give yourself some 4 plus 49.
It'd be the square root of 4 to keep things going. And -7 squared is
49.
49.
So then you get 53, and then you get 2.
R is the square root of 53. Here's a cool thing. You can take your calculator out right now, go to a decimal approximation, but is it needed? Why is that not needed? going to put in the formula, I'm going to square it and get back to 53. So our formula will be x minus 3 squared plus y minus 1
squared equals square root of 53.
just 53. Okay, this one. The next one, guys, is a little on the scary side because it says, sketch the graph of this equation by first showing that it represents a circle. What if I didn't even put that on there? What if I just asked you to graph that equation and left the rest of it off? Didn't even give you a hint that this was a circle. You have to handle them the same way because, yes, there are about 3 or 4 different types of equations that can be put into this form. A lot of times, a lot of books call that the general form, where everything is expanded, everything is brought to one side, and it's set equal to 0. We have ellipses, we have hyperbolas, and we have circles that all look like this with x squareds and y squareds. I would know this is not a hyperbola because it's an x squared plus a y squared. If you remember back to hyperbolas from last year, possibly the year before that, is you'd have one of them being subtracted. You remember that?
Yes.
The ellipses, which look like circles that are just elongated, both are x squared plus y squared. So this could be a circle or could it be an ellipse? But you can handle them the same exact way. The way you handle them is by completing the twice. So, my first step would be split it up. Mr. Konchak, why did you automatically put spaces in there? And why are there 2 on the right-hand side? What did I do to the left? Did you do to the right? Yes. And notice what's in front of x squared and y squared. Positive, but it's a 1, right? A is already equal to 1. Do I need to get rid of A then? If you remember back to what we do for completing the square, when that's the case, all I have to do is take half of B, square it, and put it in. So what's half of B in the first group?
1 squared.
So it's half of 2, which is 1 squared. What's 1 squared?
1.
Guess what, guys? Remember, I'm leaving it as 1 squared. Going over to negative 6. What's half of negative 6?
3 squared. 9.
So it's negative 3 squared. And negative 3 squared is 9. Again, why am I leaving it with negative 3 squared and 1 squared? Because that's how it's going to be when I factor it. Remember, I'm trying to make things go as efficiently as possible. And this becomes x plus 1 squared. Because the 1 that we found to be half of B goes here. So that means this one's going to become
Y minus 3 squared.
y minus 3 squared. And that equals 3. So we'll leave the graphing for you guys because it definitely will have the square root of 3 as a radius. What is the center? And r equals square root of 3. So using those 2 pieces of information, you guys could graph it. Square root of 3 is about 1.73. The last slide here is just a bunch of information comes out of your book. We can talk about symmetry. If you remember back, we talked about the parabola having symmetry, which meant that if I knew where the center of the parabola was, that means that's where the vertex was. I was able to choose values that are equal distance from the center on both sides. They're going to have the same value. So, there's different types of symmetry, guys. first one on the top here is symmetry with respect to the x-axis, which means that above and below the x-axis, it looks exactly the same. Now, would this be a function?
No.
Why? Does not pass the vertical line test. So be careful, is that when I flip this type of graph about the x-axis, it does not change it. That means it has symmetry. We can have symmetry about the y-axis. This could be a parabola if we didn't put the little hooks on the end there. And if I spun that around, it would be the same. You wouldn't be able to tell. And then we got ones that are symmetric about the origin. The origin is at 0, and it basically means that I can take an x and a negative x and swap them, and y with a negative y. And what it does with the graph is it not only flips it about the x-axis, it flips it about the y-axis at the same time. So if it is symmetric about that, it'll look the same but opposite, kind of mirrored about the origin. Okay? And again, if you look at these things here, it talks about how can I tell if it is. If I'm able to place a negative y in for y and simplify it, and it looks like the original problem with just y, then it's symmetric about the x-axis, because I'm changing it to flip over that x-axis. Do the same thing with the x's. If I can put a negative x in and it looks like the original, it's symmetric about the y-axis. Hence this. It's easier for us to see this one. Okay, y equals x squared. We know that's a parabola and it is symmetric about the y-axis, right? We all know that. Looks like this. Okay? Think of this. Put in a negative x in there. What does that equal? Take out x, put a negative x in, which means take all the values that were over here and put them over there. What's negative x squared? It's just x squared, which is the original problem. That's why it's symmetric about the y-axis. Day 2 is page 101, 37, 41, 44, 49, 56, 60, 64, 73 through 85, every 3, and 92. Have a great day.